Now that we have a general sense of how a Hello World works and some broad stroke overview of mobile development, let's see how all this fits into the concepts of Codename One. We'll accomplish that by building a small to-do list app. While we do that, I'll try to explain how everything works together in the grand scheme of things. This is what we'll end up with after the next few modules are completed. A simple to-do app that will teach us about the basics of Codename One. I chose to create a similar UI in this case, but still respected some platform conventions. For instance, notice the title is aligned differently on Android and iOS. This is intentional. I'll discuss this more in the theming section. We start by navigating to start.codename1.com, where we enter the details of our app. We use the package com.todocorp.app, but you can use whatever name you want. Ideally, you should own the domain, so no one else would grab it. Don't use stuff like com.myapp or com.codename1, which are likely to conflict with other developers. Then we define the main class name, which I defined as TODO App. You can pick any name you want though. Last but not least, we can download the app and unzip it. Once unzipped, we can open it in your IDE of choice. Any IDE that supports Maven should work. I'll use IntelliJ IDEA, which I think is probably the best and most common among Java and Kotlin developers. The hierarchy of Codename One is huge. What you see here is a partial UML diagram of Codename One components. Even when zooming in, the amount of classes is just untenable. Instead, I'll cover two tiny branches of the hierarchy to give you a general sense of the structure. Component is the base class for all of the UI elements in Codename One. It's essentially the most important and one of the largest classes in Codename One. Label is a very important class. We use it to represent images, icons, short strings of text, etc. It has very powerful positioning semantics we can discuss later. Button and a few other classes derive from label. That's why label is so important, as all these classes inherit its functionality. A button can be styled to look as anything we want. It's generally a clickable component. Radio button is a button that has a selected state. Radio buttons are arranged as a group, and only one of the radio buttons within the group may be selected at any given time. Radio buttons can appear with a check mark next to them or as a toggle button. Checkbox is similar to radio button, but lets you select multiple checks. It doesn't have a button group. Both radio button and checkbox derive from button and show the way Codename One leverages the hierarchy to share functionality across components. Moving on, container is the second most important class in Codename One. A container contains components within it. It also derives from component and as such is a component in its own right. That means we can create any UI by nesting containers and components as we want. A container can lay out in various ways, which I'll discuss soon. Form is the root of an application page or screen. Form is the container that you can show to the user. It contains a title and other properties of that type. You have one form showing at a time. Finally, I want to talk about span button, which isn't a really important class on its own, but rather a concept. Span button is a button that can span more than one line of text. It derives from container and includes a text area and a button, but acts as a button. This makes it feel like a button, but it doesn't share the same component hierarchy as a button. With that very basic overview, let's continue. So here we have the TODO app we saw earlier. We'll now break it down into the names we can later use to refer to all of these separate pieces. The status bar area is a special case. On iOS, it's reserved at the top. On Android, it resides outside of the form bounds by default. Generally, it's the area that shows the clock, battery, etc. The title area contains the status bar on iOS and also the toolbar, which handles the title, top navigation, and everything that resides on top of the form. We can add directly into this area. The button on the right-hand side of the title is called a command. It lets us add operations to the title area and also to the side navigation bar, which we don't have in this app. Everything below the title in the form is called the content pane. It's a container that is placed in the center of the form, and in it we can generally place components as we wish. That's where we build our application. Normally, when you add a component to a form, it's implicitly added to the content pane. Now that we understand the basics, let's go back to the new project we created and open the Java file todoapp.java. In it, we should see the lines that set up the UI in the start method. This is the same code we had in the Hello World app, since we didn't do anything. Notice the BoxLayout Y code. This effectively tells the form to arrange components vertically from first to last. We'll circle back to the layout code soon. Right now, let's create a new form for the TODO app. We start with something like this, where we change the title and name, then remove the Hi World label. This produces this result. Not very different, but a small step. It would make more sense to separate the code to a different class. For convenience, we will derive the form class. This is a common practice in UI frameworks, although it isn't a requirement. For instance, in the Hello World app, we just used the form without inheriting it. This is the bare bones TODO form class. We separated the code to a separate class for convenience, so we can encapsulate specific functionality. Specifically, APIs such as adding items, the floating action button, etc. This resides in a new TODO form Java file as required for public Java classes. It's identical to the previous code. We'll need to allocate and show the new class in the TODO app class as such. Notice we don't need to save the instance of the TODO form. We just show it immediately. We can create a form field, but there's no need for that. The next step is adding the floating action button to the form. It's this button on the bottom right, which we use to add to-do items. There are several changes to the code. Let's go over them one by one. Floating action button creates the round floating button. It accepts a font image constant. Font image includes the standard material design icon set. Material design defines several standard icons that you can find online. These icons are integrated into Codename One via an icon font. That's essentially a font comprised of icons, which means they can change color dynamically and scale to any size. They also take up very little memory. This makes them ideal for devices. They are used extensively in the code because they are so convenient and powerful. Here we use the add icon, which will show as a plus sign, but there are many elaborate icons available. If you're following along, notice that you'll need to add the following imports. All IDs will detect missing imports and provide suggestions on the classes to import. So I won't spend too much time discussing imports after this. One thing to keep in mind is that AWT and other APIs have classes with names identical to Codename One classes, so make sure to import the right package. One important thing I'd like to highlight is the last line, which isn't needed in this file, but is relied on in the rest of the code. The static import exposes a lot of methods for easy access. If code won't compile, make sure you have that import in place. We usually add items to containers, but a fab floats on top. This method handles the floating aspect. Since we're subclassing form, this means the current form instance. When the flab floating action button is clicked, we invoke the add new item method. We'll discuss event handling soon. We'll leave the add new item method blank for now. We'll get back to it soon enough. The next step would be implementing the add new item method that we added as a stub. Notice that this code won't compile yet, since we're relying on the TODO item class, which we didn't add yet. We create a new object instance for each item. We'll discuss the TODO item soon. The current class is a subclass of form. Form derives from container. Here we add the new TODO item, which is a component, into the form. Technically, this fits into the content pane of the form. When a form is showing and we make a change to it, we need to let the form know we finished making changes by invoking revalidate. Otherwise, Codename One would have had to constantly arrange the components over and over. This would have made the app slower. The edit method of TODO item launches the device virtual keyboard so the user can start typing the text into the new item immediately. You won't see the virtual keyboard on the simulator since you would use your desktop keyboard, but when running on the device, the keyboard would pop up instantly and let you type. Let's go back to the revalidate method for a second, as it's the most confusing part of this code. Why do we need it, and why doesn't Codename One revalidate every time we add an item? Revalidate is an expensive operation. If Codename One did it every time the UI changed, it would be very slow. In fact, platforms such as web do it all the time when it's called reflow. That's considered one of the major performance penalties inherent in web development. The revalidate operation is expensive since it needs to recursively loop through all components. If one of them changes its size, we need to rerun this recursive loop over again. There are shortcuts to make it faster, but it's still an inherently slow process. We can clarify this with an example. Let's say we have this code. With automatic revalidate or reflow, we'll have to run revalidate twice, which would make things slow. Another benefit of revalidate is layout animations. We can change the UI, and instead of revalidate, we can ask Codename One to animate the UI into place, as we do in this code. This will move component X into its place in the layout within 150 milliseconds. It's equivalent to revalidate in effect, but does that logic with style. I'll discuss layout animations again soon. Before that, let's look at the TODO item class. This class represents the individual items you can see in the app. Each one of these items is editable. We inherit container, so we can add the to-do item itself directly into the form. Text field is a component that accepts user text input with the virtual keyboard. These are the text field areas in the previous screenshot. Notice they look like regular label, but they are in fact editable by the user. We mentioned checkbox before. It can toggle between selected and unselected states. It's a subclass of button, which itself is a subclass of label. These are the checkbox components. With BorderLayout, we can position a component in one of 5 places: center, east, west, north, and south. These correspond to a center, right, left, top, and bottom of the container. It's a workhorse layout for Codename One, mostly because of the center position. By default, a component placed in the center of the border layout takes up all available space not taken up by other components. We create a text field with a value of the text passed in to the constructor. We don't want the text field to look like a text field. By default, they include a line number or a box around them to indicate that user input is expected here. In this case, we want it to look like a label, which we can do by setting the UI ID. We'll discuss this in the styling section soon. We place the text field in the center of the layout area and the checkbox to the right. Since we pick center for the text field, it will take up all the available space. Notice that center and east are constants related to the border layout, but they and other constants are defined in the Codename One CN class, which we import statically into every Java source file. We assume in the code that this static import exists in all client-side files. We do this so the code would be shorter and more readable. The checkbox is checked based on the Boolean flag we passed in the constructor. This line of code launches the text editing on the device and opens the virtual keyboard. As you recall, we invoked this in the add new item method before. We'll need the last two methods when we save the data to the device storage. After making these changes, we end up with this UI. I added 2 entries to highlight how the individual entries look. This is a good place to pause for a second and have a discussion of layout managers. We've used 2 so far, BoxLayout and BorderLayout. Let's dig deeper. First, what is a layout manager? A layout manager is an algorithm that decides the size and location of components within a container. Every container has a layout manager associated with it. The default layout manager is FlowLayout. To understand layouts, we need to understand a basic concept about component. Each component has a preferred size. This is the size in which a component wants to appear. For instance, a label, for a label, the preferred size will be the exact size that fits the label text, icon, and padding of the component. A layout manager places a component based on its own logic and the preferred size, sometimes referred to as natural size. Let's go over some of the major layout managers. A flow layout will just traverse the components based on the order they were added and position them one after the other. When it reaches the end of the row, it will go to the new row. Every component in the flow layout will get its preferred size. This is the default layout of Codename One, but it's pretty problematic for most cases because it isn't deterministic. FlowLayout is great for simple things, but has issues when components change their sizes dynamically, like a text field. In those cases, it can make bad decisions about line breaks and take up too much space. FlowLayout has several modes, including a center mode that center aligns elements. It can align elements to the right and align vertically as well. BorderLayout can position elements in the north, south, east, west, and center. Components take up their preferred size on the opposing axis. Center takes up the available space by default. BorderLayout is a constraint-based layout. That means that when we add a component, we also need to provide a constraint such as center. BorderLayout has several modes, including absolute center, a mode where the center component takes up only its preferred size. BoxLayout Y arranges components vertically, giving them the available width and their preferred height. This is great for scrolling and a very useful layout in general. BoxLayout X arranges components horizontally, giving them available height and their preferred width. GridLayout arranges components in a grid and gives every element the same size to match the preferred size of the largest element and in relation to the grid columns/rows. This is useful for grids of icons. For more complex grids, we recommend table layout, which I won't discuss now as it's a pretty advanced layout. There are also grid bag layout and MIG layout, both of which would be familiar to Java developers coming from Swing. I won't discuss them as they are both advanced concepts. Layered layout places components one on top of the other. We added some margin to each component so you can see the layers below. Normally, you would only see the gray component on top if they all had the same margin. This is a niche layout that's useful in very specific settings. We didn't discuss scrolling yet, but it's an important topic. Containers in Codename One can be made scrollable. By default, the content pane of the form is scrollable on the y-axis. However, BorderLayout disables scrolling implicitly and turns that off. Most layouts handle scrollability okay, but there are some caveats. That's why only the layout marked with check here should be used if you intend to make the container scrollable. Only one element can be scrollable within the hierarchy. Otherwise, if you drag your finger over the form, Codename One won't know which element you are trying to scroll. It's important to notice that it's okay to have non-scrollable layouts. For instance, BorderLayout as items within a scrollable container type. A good example in the TODO app is the TODO item, which uses BorderLayout and is added into the scrollable BoxLayout Y form. Layouts can be divided into two distinct groups. Constraint-based layouts like BorderLayout, table layout, grid bag layout, and MIG layout. Then there are regular layouts, which are all the other layout managers. When we add a component to a container with regular layout, we do so with a simple add method. This works great for regular layouts, but might not for constraint-based layouts. A constraint-based layout accepts another argument. For instance, BorderLayout needs a location for the component. In BorderLayout, which is a constraint-based layout, placing an item in the north places it in the top of the container. The order of adding elements to constraint-based layouts might be unimportant, but it's critical for regular layouts. To make the code shorter and easier to read, we have a few tricks. This is the regular container add code. Nothing special about it. It's here for reference. When we want to add multiple items at once, we can use Add All. Notice that this won't work for constraint-based layouts. We can chain add commands, which is pretty convenient. The add method returns the instance of the container to enable chaining. This syntax allows the usage of a constraint-based layout manager as well. In the race to make code tighter, we can make this even shorter. Almost all layout managers have their own custom terse syntax style. Most layouts have a version of enclosed to encapsulate components within. FlowLayout has a variant that supports aligning the components on a various axis. To sum this up, we can use layout managers and nesting to create elaborate user interfaces that implicitly adapt to different screen sizes and device orientations. This concludes the first part of this tutorial. In the second part, we'll discuss styling the user interface we just created, events, storage, etc. Thanks for watching, and please share this with your friends. If you like the work we're doing here, please star Codename One on GitHub and follow us on Stack Overflow. Thank you.